Yeah, so without further ado, I'm going to introduce our last speaker. The title of this talk I find is entirely captivating. It's called Architecture of a Browser-Based Filecoin Retrieval Market. It's by Mike Goelzer, who leads Product and Strategic Management at Protocol Labs. So I'm going to bring him on right now.
Hey, Cindy.
There you are. Hi.
Hi.
Welcome.
Hiding in the green room.
Glad you found your way.
Yeah. Okay, are we ready to start?
Yep.
Okay, great. Let me just share my screen and okay, so I'm not going to be able to see anything in the chat or any other visual cues because this is occupying my entire screen. So just shout, Cindy, if something is going wrong or I've muted myself or anything silly like that. Okay, so let me introduce myself. My name is Mike Goelzer. I work at Protocol Labs. I've been working a lot on the Filecoin project this summer, and what I want to present on today is a tool that I've been working on an embarrassing amount of time this summer and fall and winter. It's a browser-based retrieval market for Filecoin content. And what I'm going to talk about today in particular is the architecture of the application. So this builds on a previous talk I've given. I've given a few talks about this. They mostly demo the application, show you what you can do, stuff like that. One of them is here, this link. I know you can't click that, but if you can remember 56HRK and L or I PIDS, you can visit that for a more that's a more gentle introduction to what's going on in retrieval markets in Filecoin generally. What I want to do in this talk is focus more on the architecture of what we've built. And before I move forward, I just want to point out in the bottom left corner there, we hang out on Filecoin Slack. So if you don't have an account, you just go to filecoin.io/Slack. And then we hang out in a public channel called fil-browser-retrieval. We welcome anyone who wants to join our little community that's working on this project or related projects. So please, we would love to have you join that channel, and we can point you to other stuff that's going on. So I'm going to condense the kind of background information to just hopefully like just 2 or 3 minutes, and then I'm going to talk more about the architecture, as I said. But just really briefly, what is the retrieval market? So Filecoin is a market for data storage. You negotiate a deal with a miner, you store data on that storage miner, and then later on you can retrieve the data from that miner. But there are some use cases where you may want to publish data for a more general audience than just retrieval by yourself. And in that case, we want to create a competitive market for retrieval of that data. And the idea for doing that is to have a second market independent of the storage mining market called the retrieval market. And someone could retrieve once from the storage mining market, put that data into the retrieval market, and you can kind of think of it as like an IPFS or like a BitTorrent, or it's just a peer-to-peer marketplace where content retrieved from Filecoin can be re-retrieved by a large number of other people. This is our main repo. So what we're trying to build is a browser-based implementation of what I just described. Everything runs in a browser. You don't need to run a Lotus instance on your laptop. You actually don't need to run one anywhere. I'll tell you a bit about how it works in a minute. And you can query for CIDs, you can store CIDs, you can resell CIDs. So you can come check out our repo. Okay, so rather than doing a demo, I'm going to show a 60-second video that I think is going to be faster. Cindy, just interrupt if you can't hear the sound or can't see the video.
The first step, you have to give it your wallet. So let's start out with this example CID, just to see what it looks like to retrieve content from another browser. So we queried for it. We got one offer. That's not surprising because I have another Firefox browser running right next door, and it's already storing this CID. The one
video is on. Is it
So-
the audio?
Well, let's
You don't see the video?
I don't see the video. Does anyone in the audience see the video? Oh, they
Okay.
see it? Okay, it's just me then. Don't worry, I'll
Oh.
listen.
Oh, okay, all right. I'll resume the video where it was
As you
then.
can see, the
I can
first
also just
step,
do a
you
live
have
demo.
to
It's just slower.
give it your wallet.
Hold, sorry, one sec.
As you can see, the first step you have
I think we're about there.
using a payment channel to exchange vouchers for data, and then finally completing the transfer. So this demonstrates the peer-to-peer nature of the browser network, but on its own, that's not very interesting. How do you get content into the system in the first place? So to do that, let's take a look at a CID that is only available on the Filecoin storage network, and in particular on this miner. Okay, I query for that CID, I click buy, and what's going to happen is this browser is now going to open a connection to a proxy server that runs an instance of Lotus. That instance of Lotus will do a Lotus client retrieve, and then this browser will send funds to the proxy server to then actually receive back the bytes of this CID.
Okay, that's it. So what you just saw was two things that this application can do. Again, it's the application at that repo I showed earlier, Filecoin Shipyard / browser retrieval. It can do two things. It's a peer-to-peer network of browsers, so it can retrieve from another browser. That's the green part that you see on the left here, and then it can also retrieve from the Filecoin storage network. And I'm going to talk in a little bit more detail about how both of those functions work. So this diagram is basically everything. I'm going to walk you through it in pieces, but fundamentally, this is everything that's going on. You've got this peer-to-peer browser network on the right in green. Each of those boxes, imagine that's a browser. And then when those browsers need to publish messages to the chain, they do so via a public Lotus. That just means it's a Lotus that anyone can access. It doesn't store any wallets. It doesn't store any private information. All it does is give you a pathway by which you can publish messages onto the blockchain, and that's fundamentally what moves the Filecoin system forward. And the interaction with the Filecoin storage network, I'm going to talk about in a moment. So let's dive into a little more detail about some of these parts. Just talking about the browsers communicating with each other and how do they exchange files with one another. Fundamentally, it's a libp2p network. So if you're not familiar with libp2p, this is a great open source project, which I know and love, and you can too if you go to github.com/libp2p/libp2p is the main repo, and then there are various language implementations linked to from there. We have many different. We've implemented the libp2p protocol in many different languages. It's an extensible, upgradable protocol. It's great for peer-to-peer applications. So anyway, so this is basically a libp2p network of browsers. They communicate using Gossip, which is one of libp2p's decentralized pub/sub mechanisms. We support a couple. The best one is Gossip, a Gossip sub, also known as. And it's pretty simple. A browser can ask for content. So when the user puts in a CID, and I should just pause for a second on the concept of CIDs. So all content in that goes into Filecoin is identified by a payload CID, which is basically just a hash over the original content. So if you have a 1 gigabyte file that you want to upload, the payload CID is just computed as a hash over the 1 gigabyte of data, and then that we sometimes call that the data CID or the file CID or the payload CID. And then once it gets into Filecoin, once it gets stored on a Filecoin miner, there's another concept called piece CID, which I'm not going to go into right now because this particular tool only thinks in terms of payload CIDs. It thinks in terms of an entire file, or it's 0 or nothing. Sorry, it's everything or nothing. We deal with payload CIDs in here. In the future, I would love to work with IPLD selectors and more fine-grained control over what you're retrieving. Like from a large data set, you might only want a certain set of records. But right now, this tool is much simpler than that. So anyway, the Gossip Network lets browser clients ask for content by a payload CID, and then if some other browser has that content, it will reply saying that it has the content, and of course, it'll name its price and the multi-header where it can be reached. In terms of how the browsers transfer data from one another, so once browser A has agreed to send data to browser B on certain economic terms. Right now, we use just a pretty simple chunking mechanism, and then the actual byte transfer, we just send raw bytes. What we want to do, our next step, is to port Go data transfer. So there's a whole retrieval side of Lotus, which is called Go. It's called Go Fill Markets / Retrieval Market. Like that's a GitHub Filecoin project / Go Fill Markets / Retrieval Market. That is a set of that's a block of code, very large block of code in Lotus, and it relies on some lower level components. It basically relies on Go data transfer. And then Go data transfer relies on something called Go graph sync. So we want to take the collection of those three things, compile them into WASM. We've managed to do that. We've got that working outside the browser extension. Now it's just a matter of porting it into the browser extension. And then longer term, what we're trying to do is rewrite all of this stuff in native JavaScript. So we have one project underway to create a JS graph sync. That's the lowest level component. Then we would create a JS data transfer, analogous to Go data transfer. And then we would finally create a JS side of the retrieval markets protocol. But for now, we're just relying on a much simpler way of just moving the bytes back and forth. And in terms of storage, if you retrieve a 1 GB file, where is that stored? So it's stored in the browser local storage. We use the JS IPFS block store. We think it's a better, it's just a hash addressed block store. Based on it chunks you give it chunks of data, it stores them hash addressed, and then it can reassemble them into a file based on the CID you're asking for. So that's how the browser part of it works. Now I want to talk a little bit about the payment side of it. So when browser A is requesting a file from browser B, it necessarily implies that browser A is going to pay funds, Phil, to browser B. And the way that works is a back and forth kind of mechanism where a little bit of data is sent by browser A, and then browser B requests a payment voucher, which is a commitment to pay a certain amount of fill in the future. Then browser A sends back that payment voucher. Then browser B sends a little more data. And this cycle just continues going until all data has been transferred and all value for that data has been transferred the other way in the form of vouchers. And in order to use payment vouchers, you have to first create a payment channel, create or recycle a payment channel, which is an on-chain event. So we have to publish messages onto the chain. As I mentioned earlier, we use a public Lotus for all on-chain interactions. But because it's public, we can't put anybody's wallet on it. We can't put someone's wallet private keys on it. There's too much risk that somebody would figure out how to hack Lotus in a clever way that exposes other people's keys. So we keep all of the private keys, the signing keys in the browser, which means we need to sign all the messages in the browser. So what we do is we generate messages, all of our messages. We don't use the Lotus RPC APIs. Lotus has a very rich API. There's thousands of calls you can make. we don't use basically any of those. What we do is generate all of the messages that we want to publish on chain inside the browser. We sign them with the user's wallet private key, which is also never leaves the browser. And then we use this low-level interface mpool push to publish that message onto the blockchain. And then there are some other APIs you can use to see the result and did it execute successfully and so forth. There are some future ideas about doing delegated signing in Lotus. So you would have a Lotus where instead of having wallets on that Lotus, it would reach out. It would be given some kind of a callback whenever it needs a message signed. I don't see that coming too soon in Lotus. There's sort of higher priority things that need to be done first, but it's an idea that's floating out around there. Until then, mpool push actually works pretty well. You can look at our code. It's really not that hard, and it gives you a lot of flexibility. So, okay, now I want to talk about what turned out to be the most challenging part of the project, which was retrieval from a storage miner. So having a browser node retrieve content from a storage miner node on the Filecoin storage network. So that's the blue part in the bottom right there. Here's the dream. The dream is the browser, all of the browser nodes and all of the Filecoin storage nodes would be on the same libp2p network. And when a browser wanted to retrieve from a storage node, it would directly connect to that storage node in libp2p. It would open a stream to that storage node for the transfer. We would use, as I mentioned earlier, Go fill markets plus Go data transfer plus Go graph sync, all in one big happy WASM bundle to interact with the retrieval market side of the Filecoin storage miner, and that's how we would exchange data. So in other words, the Filecoin storage miner, one of those blue boxes, it wouldn't even know that it's not talking to another storage miner or another Lotus full node. Technically, it wouldn't know that it's not talking to another Lotus. It would just think, okay, I'm talking to a Lotus. It's requesting this, offering these payments, and that would be it. There have been some practical challenges in realizing this vision. First, in a web browser, obviously you can only make outgoing WebSocket connections. You can't make raw TCP connections. Lotus actually supports WebSocket connections, but it's not turned on in the config file by default. So we would have to convince a large percentage of miners to turn on WebSockets and advertise a WebSockets multi-adder. So that's one thing. The second is JS graph sync and the Go WASM work is not complete yet. So we have some of these working pretty well. JS graph sync can communicate with Go graph sync in kind of an isolated environment. And we can do, again, in a separately isolated environment, we can do data exchange between a Lotus miner and our own code using this WASM bundle of Go, a subset of Go fill markets plus Go data transfer plus Go graph sync. So we think we can combine all these things in a way that'll work, but they're not there yet. So those are some of the main challenges. And as a result, we put into place a stopgap solution, which is a proxy server. So that's that very dark blue box at the bottom. We've had to put that in between the browsers and any Filecoin storage node. So it works the way any proxy does. The browser sends the request for what it wants to this proxy machine. The proxy machine is running a Lotus full node, so it's capable of doing a retrieval of whatever CID the browser is asking for from the Filecoin storage network, and then it just sends those bytes back to the browser. This the pricing, the economics of this is very tricky. I don't want to create a situation where people can abuse the proxy server to make money or something like that, to get extra income for their storage miner. So what we do is we make browser clients pay upfront. They pay the proxy server two times the price of retrieving what we estimate to be the price of retrieving that CID they're requesting. And then it's a best efforts thing, and there are no refunds. So in other words, we do the best we can. It's open source code. We're not trying to rip people off, but this is very much, it's not an ideal solution. It's just a stopgap until we can get some of those better solutions working. So I think that was everything I had. Let's see. I am happy to take questions for as long as people are interested.
Great. Thanks, Mike. That was a super informative talk and very exciting.
Okay, thanks. Yeah. Sorry, I'm just looking at okay.
I thought maybe you couldn't hear me or something.
No. Hearing's good. But
it certainly sounds like browser-based Filecoin retrieval will be critical for the accessibility of retrieval markets in the future. So
yeah, there's several retrieval projects going. One is to build a retrieval. So one is one that UL ChainSafe did. It's a Go retrieval market, and it works in a very similar way. It uses gossip sub to communicate asks and offers between the nodes. It does require a full Lotus miner or a full Lotus node at least running. But that's a cool one. There's another effort underway to build an infrastructure for retrieval, which is not it's not an end user facing application, but it's basically a set of additional nodes that would kind of interact with the Filecoin storage nodes in a way to make retrievals very fast, low latency. And there's a startup called Myel, M-Y-E-L, that is trying to build a retrieval market for Filecoin also. So this is just one of several projects, but this was the only one that took up the challenge of doing everything in the browser, not using any of the Go code. We finally broke down and decided, all right, we'll use some Go code called the WASM. Yeah, but we don't require anybody to run a Lotus instance anywhere on their computer or have one on the cloud or anything like that. So I know the interface is a little raw. That wasn't a priority, but I think this could be turned into an application that would work well for end users and be simple to use.
For sure. I'm delighted to see the progress on that. You said something in your last blurb about not requiring a Lotus node or running anything like that. And that brings us to our first question. Is a retrieval market similar to a light client?
Yes. I mean, this is a classic light client. It doesn't have a full node. It depends on, it's an Infura style system. So if you know Infura, the way our system works is there's just this public cloud Lotus, and all the messages are sent to that, but it doesn't, everyone is sending their messages to the same set of cloud Lotuses. It's just on the subject of Infura. Infura actually has a Filecoin API. I would really like to use it. In its current state, I don't know if it's fair to call it read only, but basically it can't do some of the operations like transferring funds, for example, that I need. So I can't switch to it quite yet, but my hope is it'll keep getting built out. Certainly the Infura gateway for ETH is has all that stuff, so they know how to do it. Yeah.
Great. Next question is, next question out of 3. Second one is, how do you see retrieval markets evolving in the future?
Yeah, that's a good question. I think that a few things will happen. I think that the first thing that happens is, as Pooja was saying in her talk, we're in the early stages of onboarding clients to store data onto the network, right? So the first big thing was, okay, launch the mainnet, have all these storage miners ready to accept data. We now have this huge amount of storage capacity. And now we're onboarding clients who want to store data. And if they want to store data, they obviously want to retrieve it at some point. And some subset of those people are going to want it's not just a backup of my hard drive where I'm the only person who's ever going to retrieve it. It's like the genocide database, for example. You can imagine that that would be of interest to educators at a lot of different institutions. And so it's maybe one organization uploading that data to Filecoin, but it's going to be many organizations that want to retrieve it. And I think as those use cases come up, there's going to be a need for something like a Google Filecoin, some kind of an index where you can type in genocide educational material or something like that, and you can find this data set, and then you can go to the retrieval market, and you will likely find that it is cheaper on the retrieval market. It certainly can't be any more expensive because the retrieval tools let you go to a storage miner if you want to. But most likely you'll find other copies of it on the retrieval market. And I think that's kind of how it'll grow.
That's so exciting because, right, if information is just being propagated but nobody's consuming it, there's no knowledge transfer there. So that's super exciting to hear. Yeah. All right, we got our last question here, Mike. Have you looked into leveraging assembly script for your WASM support?
No, I haven't. So we're using WASM in two places right now. One of them I skipped over. We use Rust WASM, Rust code compiled to WASM for a lot of the payment channel message generation and also a lot of the signing logic. I have not looked into assembly script. No, probably should. Yeah, that's a good tip. Thanks for.
So did it just slip under your radar?
I just had. No, it was just, I try to work from a prioritized backlog, and I won't develop the main features first. There's a lot of optimizations that could be done. I can make transfers much faster, more reliable. There's error cases that we don't handle correctly now that if we did handle them, it would be much better user experience. So there's like a long list. You can see our backlog if you go to the repo, install the ZenHub plugin. It's like before GitHub had their own Kanban tools, there was ZenHub, and so we're still using that. But
yeah, so are we.
Okay, yeah, a lot of people. I didn't mean to call ZenHub. I hope their lawyers don't send me a letter now. But
yeah, we won't tell anybody. So it was great having you, Mike. Thank you very much for coming on.
Okay, well, thank you guys for having me. Yeah, and have a good weekend.
Yeah, you as well.
Bye.
See ya.